Hello students, welcome back to my channel. So let us learn one more searching algorithm. So today's searching algorithm is going to be binary search algorithm. So this is one of the very important algorithm. This gets asked in most of the examinations. And it is also a very simple algorithm, very easy to understand. So let us try and understand this. So first I will explain you what is a problem statement is. Then we will see with the help of an example the working concept behind the binary search algorithm. After that, we'll see the algorithm itself and then we will iterate that algorithm with the help of another example. All right. So the problem statement is given an element X and the data set that is in ascending order. Now, this is very, very important. So we have an element X which we need to find because this is a searching algorithm. So we are searching for X. And where we are searching in a data set. Now, this is a numerical data set or it can be any other data set. But in our example, we'll be considering a numerical data set that has to be in an ascending order. Okay, so if it is not in any ascending order, then this particular binary search algorithm is not cannot be implemented. So find whether X is present or not in the dataset. That is nothing but we are trying to do the search operation here. All right. So that is the problem statement. So given a data set in an ascending order, how do we search for an element? Okay, so there is an example here. This particular example I have taken from the website Geeks for Geek. So initially we have to find the key 23 using the binary search, and this is our given array. As you can see, we have 10 elements. The index is starting from 0 and it's end at 9. So how we are going to do the search? So initially we will take the values high and low. That is, the very first index, the very first elements becomes the low and high value is the last element. Now, using this high and low, what we are going to do is we are going to find the midpoint. Okay, so what is the formula I'm going to use? I'm going to use the formula low plus high divided by 2 here. 9 by 2 is nothing but 4.5. Of course, we are going to take only the integer part. Hence, I'm going to consider the element which is present in the fourth position as a mid value. As you can see, so 16 is a mid value. And remember that we already know that the given data set is an ascending order. So what I'm going to do is I'm going to compare the mid value with the key value. All right. So now when I'm comparing, I'm going to check and see if the key value is greater than the mid, or is it less than the mid, or is it equal to mid. So if it is equal to mid, we can directly terminate the algorithm that we have found the value and we can return the position of the mid and we say that the element is found in this particular position. If not, what I'm going to do, I'm going to check. So in this case, 16 is less than 23. So obviously it is understood that I can completely ignore this part because our data set is in ascending order. This particular key element has to be present on the right hand side. So now I'm going to focus because we also compared with the mid. I'm going to ignore this as well. Now our total focus is going to be only on this part of the data set. All right. Now what next? Again, now that I know that my element is present over here, the high value remains same. The low value from 0, I am going to push it to mid plus 1. Now remember, in the previous iteration, mid value was 4 and we also compared it with mid, so I can ignore mid as well. Now I am taking the position from next. So mid plus 1, which is nothing but 5, becomes the low value. Once again, I'm going to calculate the mid value, that is 5 plus 9 divided by 2, which is nothing but 14 by 2. Again, I will get the value 7. So the value here, mid, becomes the seventh position. So now here I'm going to once again compare 23 with 56. Now what is happening that I'm finding that they are not equal, but the key value what I'm looking for is less than the mid value. So now I can completely ignore this part. I know that my value is lying somewhere here. So by now you would have known. In the next iteration, I am going to keep the low value as it is and I am going to decrease the high value to mid minus 1. That is, now the high value is going to be 6. Okay, so that is what is going to happen in the next iteration. My high value is going to change to 6. Once again, calculate mid. 5 plus 6 divided by 2 is equals to 11 by 2 is nothing but 5.5. Of course, we are going to consider 5 as a mid. So now low as well as mid value is same. Okay, that is fine for us. So once again, I'm going to compare if mid is equal to the key value. And in our case, we find that mid is equal to key value. Now I will return the position of the mid, and I know that the key value what I'm looking for is present at the position 5. So this is how the binary search algorithm works. All right. So let us quickly see the algorithm. So what is going to happen is we are going to use a iterative method where I'm going to take a loop where until the pointers low and high meet each other. So I have a low value which is starting from 0 and high value which is the highest value. Until they meet each other, I can continue this iteration. Suppose they are meeting each other or the both the value becomes equal and still we have not found the element, then we can say that the element is not present in the data set. Okay. So initially, I'm going to start here and first thing I will do is calculate the mid value. Like we have seen, mid is equal to low plus high divided by 2. The moment I get my mid value, first thing I will do is x is where my search value is my x is equal to array of mid. Okay, that is the first thing I will search. The moment I say that it is equals to mid, I will return mid. Mid will have the position. I'm going to return that. If not, I'm going to check. Else if is the value I'm looking for, is it greater than the mid value? If it is greater than mid value, as we all know that we have to only look at the right hand side. Hence, I will change the low value to mid plus 1. Otherwise, which means the value is present on the left hand side. So I have to change the high value. So high value will move from mid minus 1. Okay, so that is how we will continue the iteration until we find the value. Okay, so let us quickly take another example and try and iterate this algorithm. So I have low value is equals to 0 and I have high value is equals to 9. Okay, let us see. The loop was saying that low value should not cross the high value, which is nothing but it should be, I can say that less than or equal to high value, which is true in our case initially. So this is my low value and this is my high value. All right. Now I'm going to calculate the mid. So mid is going to be 0 plus 9 divided by 2, which is nothing but I'll take a round value of 4.5, which is nothing but 4. So this is my current mid. Okay, so mid is nothing but mid value is 4. Now I'm going to compare if A of mid is it equal to X. Now what is my search element? Let us take the search element as 19. Okay, in our case, now I'm checking whether 27 is equal to 19. So in this case, it is not. Okay, because here we have 27. So if it is not equal to the mid, then what I'm going to see, I'm going to check whether my element is lying on the left hand side or the right hand side of my data set. In order to do that, what I will do, I will check whether x is greater than a of m. So is it so? What is my x value? X value is 19 and a of m is nothing but 27, which is also false. Hence, I will check. Obviously, if it is not equal and if it is not greater, it is understood that it is less. So in case if it is less means the value is lying somewhere over here. Hence, I need to bring my high over here. So what is the condition for that? High value will become mid minus 1. So the new high and low values will be now low is equals to 0 and high is equals to mid was 4. So it is now going to be 3. So now we will only focus on this. Okay. Now, once again, I have to calculate the mid value. Mid is equals to 0 plus 3 divided by 2, which is nothing but 2.5. I will only see the integer value, hence 2. So 2 is nothing but over here. Now, my new mid value is going to be here. Okay, remember simultaneously we are also checking that low value should be less than or equal to high, which is of course low is less than or equal to high. So now my mid value is here. The very first thing what I'm going to do is I'm going to check whether x is equals to a of mid. So what is the x value? X value is 19 and a of mid now it is also 19 and which means we have found our element. So the moment we find our element, we will terminate this particular algorithm and we will return the position of m. M is nothing but the position. So this is nothing but 2. So we know that. So in this particular data set, my search element present in the position 2. Okay. So what happens in case if I don't have an element? Suppose my x value is X value was 2. Okay, let us continue this. So I find the mid here at 19. Okay, so now I compare whether 2 is equal to 19. Okay, this is when X value is 2. Remember, this is a different example I'm taking. This we have found the element when X is equal to 19. Now, suppose if X is equals to 2, what is going to happen? So I'm comparing 2 with 19. Of course, it is not matching. Next, I will see whether x is greater than a of m. So my x is 2, a of m is, of course, 19, which is also false because 2 is less than 19. Hence, I know that my value is lying somewhere over here. Okay. Hence, once again, the high value will be changed to high value will become mid minus 1, which is nothing but 2 minus 1, which is nothing but 1. So the new high value is 1 and the low value is 0. Okay, which means we are focusing over here. Once again, calculate the mid value. Calculate mid value. 1 plus 0 divided by 2 is equal to nothing but 0.5, which implies that 0 is the new mid now. So my mid when x is equal to 2 is going to be this. What I will do, I will compare if mid x is equal to my mid. So x value is 2 and the mid value is 10. 10. It is not. So which means that I need to check if it is greater or less. Okay. Now I am comparing whether 2 is greater than 10, which is of course false. So which indicates that the value which I'm looking for is less than mid, which means I need to look on the left hand side. But we do not have any value here. Let us see what happens. Okay, now remember the lower and higher value what we have. So we have here high value 1 and low value 0. Now, when the value which is found on the left hand side, what is going to happen? I have to move my, the value is not found here. Of course, I need to move my high value to this side when I see that the value is found on the left hand side. So high becomes mid minus 1. And what is the mid value in our case? It is 0. So high becomes 0 minus 1, which is nothing but minus 1. Okay, now what is happening? My low is 0 and high is minus 1, which means the low is not less than or equal to h. This condition itself fails, which means we'll come out of the algorithm. We will exit the algorithm and we can simply print the element is not found. So this is how the binary search algorithm works. So if you see comparison between the binary search and linear search, which we learned in the previous session, in linear search, we were taking a key element and we were looking for each of the value. So compared to that, in binary search, we are only looking at the half part. Okay. Even in this, we are going to completely reduce the searching data set. But remember, it is only works on an data set which is in an ascending order. Hence, if your data set is not in a sorted way, then your binary search will not work. So in that case, you have to go for linear search. All right. I hope this is clear, the difference between them. So what about the time complexity and the time complexity? The best case is order of 1, which is constant. The average case is order of log n. And worst case is also order of log n when it comes to the time complexity. And this binary search, like your linear search, is also used in many places. The application is vast, even in indexing, data storing everywhere. This particular, even in the networking, also data binary search is used. All right. So that's all in today's session, students. Thank you for watching. Keep learning.